Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have 81 to the power of k plus 9 to the power of k is equals to 72, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. So I hope so you like this method, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem. So here the very first thing we are going to do is first we need to make the factors of 81, and we rewrite this equation as we write 81 as 9 square and its whole exponent is k, plus this is 9 to the power of k is equals to 72. And now here further in the next step we need to use here the nice exponential. You know about that. If we have a to the power of m to the power of n, so here we interchange both of these two exponents and it will be written as a to the power of n to the power of m. Okay, so according to this rule of exponents, here we just interchange both of these two exponents, and after interchanging these exponents it will be written as 9 to the power of k and its whole square, plus this is again 9 to the power of k is equals to 72. And now here you see that the bases of both of these two terms are same, so that we will take here the base of this term is equals to x. So we have x is equals to 9 to the power of k. When we substitute this value of x to the above equation, it will be written as in this form. So we have when you put this value here, it will becomes x square, plus when you put it here it will becomes x is equals to 72. And now further you see here this equation will becomes a quadratic equation in x variable. So you know about that there are three methods to solve the quadratic equation. The first method is factorization method, second one is completing square method, and third one is by applying the quadratic formula. So here we apply the quadratic formula to solve this quadratic equation. So for this we move the 72 from right hand side to the left hand side, and it will becomes x square plus x, this is positive becomes negative 72, and this whole equation is equals to 0. And now here in the next step we just make the factors of this equation. So we need to make the factors of this equation, and here we break its middle term to make the factors of this equation. So here we write this plus x as in the form of 9x minus 8x minus this is 72, and this whole equation is equals to 0. And now here in the next step we need to take common x from here, and when we take common x we get the remaining values are x plus 9, minus when you take common minus 8 from here we get the remaining values are x plus 9, and this whole equation is equals to 0. So further in the next step here we take common x plus 9, and when we take common x plus 9 we get the remaining values are x minus 8, and this whole equation is equals to 0. So here in this way we can easily make the factors of this equation. And now we break this equation and we write x plus 9 equals to 0 separately, and x minus 8 is equals to 0. From here we easily get the value of x is equals to minus 9, and from here we get the value of x is equals to 8. So here finally we have these are the two roots of the given equation. But in the start of the problem you see here we will take our x is equals to 9 to the power of k. So we back substitute this value here. So when we put the value of x here, it will becomes 9 to the power of k is equals to minus 9, and in this case we have 9 to the power of k is equals to 8. So here you see that in the left hand side we have an exponential function, and you know about that exponential function always gives us the positive value. So it is not possible that an exponential equation gives us the negative value. So that's why we rejected this case, and we will just proceed here this case only. And in this case here first we need to make the factors of 9 and 8, and we know we write this 9 as 3 square and its whole power k is equals to, here we write this 8 as 2 cubed. So further in the next step here we need little bit more simplifications, and it will be written as 3 to the power of 2k is equals to 2 to the power of 3. And now here we are ready to take the log on both of the sides in order to find the values of k. So when we apply log, it will be written as log of 3 to the power of 2k is equals to log of 2 to the power of 3. And here we move this 2k in the front of this log, and it will becomes 2k times of log 3 is equals to, here we move this 3 in the front of this log, and it will becomes 3 times of log 2. And now here further, because our target is to find the values of k, so that's why we move this 2 and log 3 from the left hand side to the right hand side. So after moving this to the right hand side, it will be written as in this form. So we obtain k is equals to 3 times of log 2 divided by 2 times of log 3. So here we need little bit more simplification to write our answer into the simplified form. So we have this is 3 over 2 times of, we write this term as log of 2 with base 3. Okay, we combine both of these two terms by using the property of log. So this is the final answer of this problem. And now here in the next step we need to verify that is this value of k be the solution, or is this value of k be the extraneous root. So for verification we need to copy down given question statement. Here it is 81 to the power of k plus 9 to the power of k is equals to 72. And here we substitute the value of k into the left hand side and we check its behavior. So we have 81, we write this 81 as 9 square, and its exponent is k. The value of k is 3 over 2 times of log 2 with base 3 plus, in the same pattern we write this 9 to the power of k, we write this 9 as 3 square, and its whole power is k, and our k is equals to 3 over 2 times of log 2 with base 3. And here we check that is this equals to 72 or not. And now you see here this 2 and 2 are gone, and we will get here this is 9. Here we obtain 9, and we again write this 9 as 3 square, and its whole exponent is 3 times of log 2 with base 3. And now here further in the next step we have this 2 and 2 are gone, and we obtain here 3 to the power of 3 times of log 2 with base 3. And here we check that is this equals to 72 or not. So here we multiply these two exponent, 2 times 3 becomes here 6, and we write it as 3 to the power of 6 times of log 2 with base 3 plus, here we move this 3 to the exponent of this term, and it will becomes 3 to the power of 2 cubed with base 3 is equals to 72 or not. Further here we move this 6 to the exponent of this 2, and it will becomes here 3 to the power of log of 2 to the power of 6 with base 3, and plus in this case we have 3 to the power of log base 3, and 2 cube becomes here 8 is equals to 72. And now you see here this log 3 log with base 3 and this 3 are gone. Similarly this log base 3 and this 3 are also gone, and we will get here you obtain 2 to the power of 6 plus 8 is equals to 72 or not. So finally we write this 2 to the power of 6 as 64 plus 8 is equals to 72, and you clearly see here we get 72 equals to 72. So this shows that the value of k is equals to 3 over 2 times log 2 with base 3 satisfied our given question statement. And this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.